Hey guys, welcome to our senior secondary physics. In this video, we're going to take a look at a topic entitled measurements. Some books or some people call it introduction to physics, but in this video, we're going to call it measurements. For those who are doing grade 10 for the first time, I'm going to introduce to you everything and be assured that this is the first thing you learn when you start learning physics. Without further ado, let's get started. So just like other videos or other topics on our channel, we first start with a topic map. For those who are watching this video as their first video on our channel, a topic map is just a map of subtopics which shows you the subtopics that are under this given topic. Then it will show you how these subtopics are related. This will help you in planning when it comes to which video to watch. There could be instances where you want to skip a video. So before you skip a video, you have to see, is this video necessary for that video or that topic, that subtopic that I want to study? So here is our topic map. So we'll start with introduction to measurements, where we're going to learn various things to measure. I won't go into details. Then we'll learn three most important things that will come from there, and we'll learn how to measure them or anything that has to do with their measurements. And those three things are: the first is the length, then there will be time, and finally mass. So physics is a science that studies the physical or the measurable physical aspect of nature. In simple words, I can say physics studies those parts of nature which can be measured. And because of that, we can say physics involves physical quantities such as weight, distance, time, temperature, and others. Weight can be measured. You can measure weight. Distance can be measured. You can measure the distance from point A to point B. Time can be measured with your watch, of course. Temperature can be measured. You can measure the temperature of your body. So these are part of nature that can be measured. So that's what physics is all about. So there are two types of such physical quantities. So all these can be categorized into two types. The first are called scalar quantities. So what is a scalar quantity? A scalar quantity is a quantity with only magnitude. Magnitude means size. So a quantity that only has size, it's called a scalar. I'll explain that in details. Let's go to the other type of quantity, which is called a vector quantity. So a vector quantity is a quantity with both magnitude and direction. So a vector quantity is a quantity with both size and direction. So to make you understand the difference or what I mean by having size and direction, let me use this part here. So let's say you measure this line to be 20 meters. So if I tell you that I've measured the line and it's 20 meters, what comes into your mind? You know that it's something that is 20 meters long. But how it's drawn, you won't be able to tell. You won't be able to tell if it's drawn like this or drawn like this. So such quantities where doesn't matter the direction, all you need is a number and of course a letter like m or meters at the end of that number, like 20m, which means 20 meters. Such quantities are called scalar. They only care about the size of a quantity, not the direction. Why is that we're so interested in direction? Let's take a look at what a vector quantity, an example of vector quantity, so that you understand why direction is important also when it comes to physical quantities. Let's say we have a box, a big box that's supposed to be pushed. And let's say you are on a phone call and your friend is the one who's supposed to push that box. Then you tell them to push it with a force of 20. So they push it with a force of 20. So force is measured in newtons. In short, whenever you read or hear someone say 30 newtons, 40 newtons, just know that they're talking about force. We're going to learn all that. So, so you tell your friend that for that to be moved, it needs 20 newtons. So your friend on the other side of the phone will understand that it needs 20 newtons, but which direction? Where should they push? Where should they apply that 20 newtons? Is it here or is it here? Because they can also apply 20 newtons here, but depending on which direction you want the box to be, you can tell them the exact point they are supposed to push. You can say apply a force of 20 newtons towards the left. So your friend on the other side will know that they have to apply 20 newtons on the left side of the box. So force is a vector quantity. Why? Because you can't just say 20 newtons then you keep quiet. You have to always state the direction. You have to state 20 newtons on to the left, 20 newtons to the right, 20 newtons downwards, 20 newtons upwards. So such quantities where you need to have information about direction for you to have an idea of what exactly is being talked about are called vector quantities. So a vector quantity actually is made up of a scalar quantity and direction. The size is a scalar quantity. So for example, this one, 20 newtons is the scalar part of a vector quantity. Then what makes this scalar quantity to be a vector quantity, what qualifies it, is when you add direction. When you say left or right, that's when it becomes a vector quantity. So whenever we're talking about a quantity and there's no need to know direction, then it's a scalar quantity. And whenever we're talking about a quantity and there is a mentioning of direction, if they say 20 degrees south, then know that they're talking about vector quantities. So here is the table which gives us examples of vector quantities and scalar quantities. So examples of vector quantities include force, which we have already discussed, displacement, which is distance but with direction considered. If someone moves 20 meters in let's say in the western direction, so we can just say that person has a displacement of 20 meters. So when of course you are talking about displacement, it means the direction has already been discussed. You all have agreed of the direction you're talking about, which means both of you know that you're talking about west. Velocity, it's also a vector quantity, which is speed but with distance considered. So I've talked about force, displacement, and velocity. Then we move to scalar quantities. Examples of scalar quantities include mass, distance, and time. So mass is just the quantity of matter in an object. Those who can remember from grade 8 or grade 7. So that bag of meal, the 25 kg, that 25 kg gives us an idea of the quantity of meal in it. If we change, you remove meal, put stones, then that won't be 25 kg, it will be something else. Also, we have got distance, which we have already discussed, and also time. Time has no direction. So time is just time. When we say 2 hours, we all know what 2 hours is. You can't say I ate or I moved 2 hours west. That doesn't make sense because someone won't have an idea of where you were after 2 hours, but they'll have an idea of that the time that has passed is 2 hours. Doesn't matter which direction you are taking. Yes, don't think too much about this. Just know that vector quantities, they consider two things: size or magnitude, and direction. And scalar quantities only consider size. And also know some examples: force, displacement, velocity as examples of vector quantities, and mass, distance, and time as examples of scalar quantities. So when we're measuring, we need units. Units help us to know what physical quantity we are dealing with. If I say I'm 20 meters odd, it doesn't make sense. 20 meters odd, what does that even mean? Yeah, so But when I say I'm 20 or 30 years, then someone will know that I'm talking about age. So at the end of numbers, we put letters that help us know what kind of a physical quantity we are talking about. So those units are called SI units. So SI stands for Systeme International de Units. Of course, the way I'm pronouncing it must be wrong. This must be French. So SI is Systeme International, which means International Systems of Units. So at sometime, I don't know when, maybe 1970s, 1980s, countries came together to to create standards of units, or to create units that they are going to be using, so that when Zambia is trying to sell copper to Britain, then when they said 20 kg of copper, Britain will know that they're talking about this. So because some countries are using strange units, like there's one country which is stubborn, United States of America. It uses other units, doesn't use the SI units. For example, instead of kg, it uses pounds, if I'm not mistaken. So that's the it's important to have a standard, so that someone from one country can understand someone from another country, because they all use the same units. So the SI units are the standard international units that were agreed at some point in time. So examples of this, for example, we have got 20 kg. So 20 kg, everybody knows kg, it's mass. So 20 kg means we're talking about the something that has a quantity of 20 in it. We've got 40 seconds time. We've got 32 years age, like I've explained. We've got 2 meters per second. It's okay if you don't know what units meters per second are, but they are for speed. So note that units are written in different ways. For example, kg is made up of 2 letters, seconds 1 letter, years, or this is supposed to be just y. Yeah, but it's okay. We're not going to be dealing with this. Then we also have meters per second, which is for speed. So these are different units, and we're going to study them in details. Let's do so. So the SI units are in two types. The first are called base units. The word base is taken from the word foundation, like the foundation of the house. It means these are the base upon which others are built. So they are defined as, these are standard units of measurement for the standard quantities. So there are 7 quantities that those people who made agreed to be agreed on. They agreed that these quantities are going to be called standard quantities. So the units that are used to measure those standard quantities are called base units. Examples of the standard quantities include mass, length, and time. Of course, the next subtopics are going to concentrate on mass, length, and time. So the other types of units are called derived units. So to derive is to come up with something from something else. So derived units are units that are formed by combining different base units. Like I said, base units are like foundation. Then things that are built on top of the foundation are the derived units. So derived units are defined as, these are units derived or made from the base units. So the table here gives us examples of base units and derived units. So examples of base units include meters, which are the units for length, represented by letter M. Of course, there are other ways in which meters are written. In their smaller units, we can have centimeters, millimeters, nanometers. Then in bigger units, we can have kilometers, but they are all meters. Then we also have kg, which are the units for mass. We also have seconds, which are the units for time, which also has got its bigger units, such as hours, centuries, decades, millenniums, just like that. Then for the derived units, we have got this one, a good example, m squared, which is meters squared. So of course, a base unit is meters, but because of that 2 on top, it becomes a derived unit, a unit that is made from the base unit. Then the second one is meters. per second. That can stroke means per. Yeah, it's pronounced as per. So meters per second, which is made up of meters and second, or length and time. Also have kilogram per meter, which is made up of mass and length. So this concludes the first part of measurements. Watch out for part 2. Make sure that you like, share, and subscribe. For any clarification, you can use the comment section below. Happy solving.